All right, so an empty 1 liter bottle sits in a room with an air temperature. So temperature is 22 degrees Celsius. Oh, this is chapter 12, number 23. The volume is obviously 1 liter. If the bottle is immersed in ice water with an opening in the bottle barely above the level of the water, does the net amount of air enter or leave, and how many moles of air enter or leave? Okay, so if we're saying ice water, then we're assuming that the temperature of the water is 0 degrees Celsius. Okay, so what should happen to the air inside the bottle when you cool it from 22 to 0? It should shrink, right? The volume of the air should go down. Therefore, air enters the bottle. How many of you got that? Okay, a couple. Right. Does it make sense to you? Right? Think of a balloon. If you put a balloon over cold water, it shrinks. If you put it over hot water, it expands. That's simply a relationship between the kinetic energy of the particles and the temperature. Temperature is a measure of what? Average kinetic energy. Okay, temperature is the average kinetic energy. And if particles have more kinetic energy, then they will take up more volume because they'll smash into the container. They'll expand to fill up a larger container. If they have less kinetic energy, they're less mobile. Yeah.
Is ice water always 0 degrees Celsius? In a question of a book.
Yeah, in a question in the book, yeah. If you have water with a bunch of ice in it, unless they tell you it's 0, it's not 0, just assume 0. Okay. Then the question is, how many moles actually fit in there? Or how many moles entered the bottle? So does it make sense to you that all I need to do is find the new volume, subtract it from 1 liter, and I'll be good, right? So, yeah, I could use probably Charles' law or something, but I'm just going to use the ideal gas law because that requires no thinking. Or at least minimal thinking. What is true about an open bottle before and after you cool it, about the pressure of the air inside the bottle? That's the same, so that goes away. So now I just need V2. V2 is V1 times T2 over T1. Uh-oh. T2 is 0, right? So does that mean my air ceases to have a volume? Yeah, we have to be in Kelvin, right? So this is going to be 295 Kelvin, and this will be 273 Kelvin. Of course, when you go to college, please do me a huge favor and your chemistry teacher a favor. Don't write degrees Kelvin. That makes your high school teachers look like idiots, and I don't need your help. Okay, so I just put Kelvin, and we're good there. So there you go. Now we're going to take 1 liter, multiply it by 273 over 295. That's a temperature decrease of around 10%. So I'm guessing it's going to be around 0.9 liters. What does the math come out to be? 0.93 liters. Okay, so the volume, V2, is 0.93 liters. Does that make sense? Does that give us the answer? I don't think so. They said how many moles enter or leave the bottle. All right? So, do we know the volume of the moles that entered? Or do we know the volume of the air that entered the bottle? Yes, we do, right? It's 0.07. So, the delta V is 0.07 liters. Does that make sense to everyone? Okay. What is, based just purely on your book, what is STP? Did your book mention this? Standard temperature and pressure. Standard temperature and pressure. So standard pressure is, obviously you could guess this, 1 atmosphere, or, Janelle, How many pascals is 1 atmosphere? I think you got to start it off with the correct answer. There's one there. So Taj, can you help her out? 0.013 times 10 to the 5th Pascal. Okay, so actually that's pretty good. You guys kind of had an idea, and you didn't really study that, so that's excellent. Okay, basically 101,000. Basically 100,000 pascals is 1 atmosphere, roughly. So if you're doing, you run into some situation where you need to do calculations of pressures, there you go. Just remember 1 times 10%. So what is the standard temperature? Yeah, standard temperature is 0 degrees Celsius, or 273 Kelvin. So luckily, that's the temperature of our gas. We have a volume of 0.07 liters at 273 Kelvin. Well, the key thing, this is the fun one, 1 mole of gas at STP is how many liters? 20.4. There you go. Remember that from chemistry? 22.4 liters. So there you go. The number of moles is going to be 0.07 liters over 22.4 liters per mole, which is going to be some very tiny number. So how many moles is that? Because that's 7. So that's almost like 7 divided by 22,000. So 1,007 would be 1 over 3,000. So it's like 0.0003 or something. 0.003. Sorry. What is it? The actual answer? 0.00315. Oh, okay. 0.00313. I'm sorry? Yeah, whatever you want. Alfred wants to do scientific notation. I laud him for that, so that's good. Minus 3 moles. Laud him for that. So this is a classic use of ideal gas law. Know it, live it, love it, breathe it.